Okay, geometry, let's do some examples for volume. Before we do some examples, we're going to have to write down our volume formulas for each of these shapes. So please make sure you've watched the first video on vocabulary, because there's some really important things in that one that I won't be talking about in this one. So this first shape over here is a sphere. And we have a cylinder and a cone. One thing to remember about these shapes, if I look at the sphere, does the sphere have a base? No. It does not have like a flat surface that it sits on. If I look at my cylinder and my cone, they both have a flat surface to sit on. That's that bottom part of them right down here. And the base for both the cylinder and the cone is a circle. So base is a circle. Base is a circle. But for the sphere, there's no base. So we're going to use the idea of this base to help us figure out our volume formulas for each of these shapes. So we need to look at the different parts of each of these shapes. So the one thing that each of these have in common is each of these has a radius. Starts in the center and goes to the edge. So the sphere has a radius. The cylinder's radius is right here. And the cone's radius is right here. So the cylinder and the cone have their radius along the base. But the sphere doesn't have a base, so its radius is just right there. Each of these shapes has a circle kind of in it if you look at them, right? So each of them is going to have pi in their volume formulas. So let's start with the sphere. So the volume of a sphere is equal to 4/3 pi r cubed. Now, volume is how much stuff is inside. Volume is something only three-dimensional shapes have. So there's going to be a cubed on our units. It might be cubic feet, it might be cubic inches, inches cubed, miles cubed, centimeters cubed. The other two shapes are not going to have a cubed on their radius because we're going to multiply by the height of each of these others. So they won't look the same as the volume formula for the sphere. But we need to remember units for volume units are always cubed, like inches to the third. Always. Even if it doesn't look like it has cubed in the volume formula, it does. It's just in a weird place. So let's talk about the volume of a cylinder. So the volume formula for a cylinder, if we think about volume, we need one other piece. We need the height. So this is the height for the cylinder. It's basically how tall is it from the top to the bottom. This line right here represents the height. Our cone also has height. And each of these make a 90-degree angle with the base. Sometimes on a cylinder you'll see height drawn right here, right in the middle of the cylinder. That should be the same length as the height drawn on the outside. Otherwise we did something wrong. So volume for a cylinder. Volume is equal to, the way we do this is we do the area of the base, which is a circle. So the area of a circle is pi r squared. And we multiply that by the height. So volume of the base times the height. So volume of a cylinder is pi r squared times the height. Now we need to do the volume of a cone. A cone is weird because it doesn't go like straight up and down in the way that a cylinder does. It's got kind of these like slanted edges, but it still has a circle for its base, so we're still going to see pi r squared in there. Problem is, a cone isn't going to be the same volume as a cylinder of its height. In fact, a cone has a third the volume. So what we're going to see for our volume formula for a cone, volume is equal to a third of the volume of a cone. So a third the volume of a cylinder. So volume of a cone is equal to 1/3, and then we're going to have the volume of the cylinder formula. Pi r squared times h. So volume of a sphere, volume of a cylinder, volume of a cone. Write these formulas down somewhere so that you can have them. I think it's interesting to notice, it helps me remember, that volume for each of these, if I'm going to have a fraction, the fraction is going to be something over 3. So sphere is 4/3 pi r cubed. A cone is 1/3 pi r squared h. So let's do some example problems. So let's get a little more space so we can write some more problems. Okay, find the volume of the cylinder in terms of pi. So if you hear me say in terms of pi, that means we're going to just leave pi in our answer. Don't have to do a big giant calculator. So let's draw this cylinder. So we're going to have a cylinder, and it's going to look like this. There's my top, comes down, here's my base. So I'm going to draw a radius in here. Starts in the middle, goes over to the edge. I could draw my radius on the top or the bottom. Doesn't matter, this radius would be the same either way. So I can tell you radius is here or radius is here. Radius is 8 inches, which means this radius must be 8 inches. Has to be the same in a cylinder. Then I'm going to tell you that the height is 13 inches. So height can be outside, or again, I could draw a height here on the inside, and it would still be 13 inches because it's still the same cylinder. So it doesn't matter which spot I draw it in. So I need to write down my volume formula for a cylinder. Always got to write the volume formula down before we start. So volume formula for a cylinder. Volume is equal to pi times r squared times h. And I went ahead and color coded it for us. So pi, we're not going to mess with it because we want our answer in terms of pi. So volume is equal to pi times r squared times h. So my radius in this one is 8. So that goes here and gets squared. And my height is 13. So 8 inches times 8 inches times 13 inches. So we're going to just grab a calculator, and we're going to do 8 squared times 13. You could also do 8 times 8 times 13. When I do that, what I get is volume equals pi times 832. Standard form says switch these. So volume equals 832 pi inches cubed. Remember, we said our units are always cubed. So this is the volume of the cylinder. Okay, let's try finding the volume of a cone next. So I'm going to move in a little bit more space so we can do another example. Volume of a cone. So I'll find the volume of a cone. As a decimal. Rounded to the nearest tenth. That means 1 decimal place. Okay, so my cone is going to look like this. So I've got the edges of my cone. The base of the cone sits kind of right here. Then I've got the height is right here. And that is 16 yards. And then I've got a radius. The radius goes from the center over. And the radius is 7 yards. Let's make sure we remember this is height equals. Okay, so first thing I want to do before I go any further, I'm going to write down the formula for the volume of a cone. Volume is equal to 1/3 times pi r squared h. So this one's pretty easy. I'm just going to plug the numbers in. So I've got volume equals 1 divided by 3 times pi. If I want to make my life a little bit easier, what I'm going to do is multiply this real quick. 1 times pi is pi over 3 times 1 is 3. So volume is equal to pi over 3 times the radius, which is 7, squared times the height, which is 16. So what I'm going to do first is I'm going to grab my calculator and I'm going to do 7 times 7 times 16. And what I get when I do that, I get 784. So I've got volume is equal to pi over 3 times 784. I can do that over 1 if I want. So what I'm going to do for my next step is I'm going to multiply across, and I get 784 pi, and then multiply 3 times 1, I get 3. So now this helps me put it in the calculator. I'm going to do 784 times 3.14, and then divide that by 3. When I do that, I get 820.58. Now my problem said round to the nearest tenths place, so that means this should be my last decimal. So I have to take a look at the number after it and see what I've got. So I've got 820.58. The 8 tells me that my 5 needs to go up. So my answer is 820.6. That is rounded to the nearest tenth. But now I got to make sure that I put units on this. So my units were yards, and it's volume, so I'm going to say YD to the third. So cubic yards. Okay, we're going to do 2 more problems. All right, next problem. Let's find the volume of a sphere. Find the volume to the nearest whole number. Use pi equals 3.14. So if you don't have a calculator that does that does pi, you can type in 3.14 is what that means. Okay, so let's draw our diagram. So I've got a sphere. I usually start drawing spheres by drawing the outside edge like that. I'm going to put my radius right here. I'm going to draw kind of a curved line showing where the outside edge sticking towards me is, and then a dotted line like it's going through the back. So my radius is this right here, and let's say my radius is 7 inches. So I'm going to find the volume of the sphere. So again, first step in all these problems, write your volume formula down. Volume is equal to 4/3 pi r cubed. So I think the volume of a sphere is actually pretty easy because I only have one thing to plug in. So volume equals 4 divided by 3 times pi times the radius cubed. And my radius in this problem is 7. So first thing I would do is 7 times 7 times 7. And that gets me 343. So volume is equal to 4 divided by 3 times pi times 343. So since it says use 3.14 for pi, I can do 343 times 3.14, and that gives me volume is equal to 4/3 times 1077.02. So the next thing I need to do on this one is times 4. So I'm going to do 1077.02 times 4, and then I'm going to divide that by 3. And my answer is volume is equal to 1436.02. Now my directions say nearest whole number, so that means I look at this number to tell me if my 6 needs to round up. This number is a 0, so that means my 6 doesn't round up anywhere, and I just have a final answer of the volume is 1436 inches cubed. And that is finding the volume of a sphere. So we had 3 different shapes this week, finding the volume of each of those. Your classwork practice problems are going to have some word problems probably, but all you need to do is try and find diameter, radius, height, something like that in there, and it should be pretty straightforward. Again, make sure you took notes on both videos. Make sure you write down any questions you have, and I will see you soon on Zoom.